Hello, my name is Lindy Humphrey, and this is my lab report for Lab 1, Constant Velocity of Physics. To introduce this lab, the purpose of this lab experiment was to observe the motion of an object moving at constant velocity and then analyze the video taken of our object, which I chose to be a ping pong ball, through Tracker to extract the object's positions and its corresponding times. It also asked us to compare the observed data to predicted data of the ping pong ball, which we will observe in a model in Google Sheets. This lab also gives a better understanding of Newton's second law by showing the interaction between a system and its surroundings in the real world. The result of this experiment shows that the position of the ping pong ball we used as our object in the observed data will be slightly different than the predicted value, but will show how it moved at a relatively constant velocity as time went on, showing Newton's second law. To expand more on Newton's second law, it is also known as the momentum principle. This is a very important concept in physics. It states that the net force of an object equals the change of momentum over the time of which it changes, represented here in this formula. We can also use it for the velocity update formula, which is this one. This is important because it shows the relationship between forces and motion, and we can calculate the acceleration, velocity, and position of an object with these known forces. Objects only accelerate or change if there are forces on them, and this law shows how much an object will accelerate for a given net force. Here is a video of my ping pong ball rolling across the floor at relatively the same speed, and each diamond shape is identifying its position at each frame and then charting it as we see here on the right to represent its changing position that we observed. However, now we must make a computational or predictive model to compare the observed position to what we predicted it to do based on these fundamental physics principles. Some initial analysis and conditions we need to compute the predicted position over time is shown here. But first, let's make sure that we have identified that the system in this experiment was the ping pong ball and that the surroundings include the floor it was rolling across and the earth, along with Earth's influences. First, we identified that the total duration of the ball rolling was 0.583 seconds, and that the initial position taken from Tracker is the vector 1,624 meters in the x-spot. Then we need to calculate the initial velocity with the first two time frames shown here, and we can get negative 2,352.9 meters per second in the x-spot. Work of how to do so is shown right here. And then we need to use that info to fill in our code on GlowScript to get the predicted data. Here we put in our initial position and velocity vector that we just identified, change delta t to 1 over 60, as that was the amount of frames per second it was filmed in, put our total time to be the duration of time, and then we set net force to 0, as constant velocity means no net force at all. That the data observed from Tracker and the data that our code gave us for the predicted data, and put it all into a Google Sheets chart in order to graph and compare the observed and predicted values in this model right here. As we can see, as time moves on, our observed data starts to diverge from our predicted values, while still relatively linear, but that could have been from a number of external factors. These possible errors or outside forces include forces such as friction, air resistance, rounding errors, and errors in the position tracking, or even if the ball wasn't moving straight enough for the video system. One of the questions that we had in this lab was a what-if question, and it states when you analyze your video data in Tracker, you made the choice of the orientation of the axes. Discuss briefly how your results would change or how they would remain the same if you were to flip the axes, or if the positive x and negative x were interchanged. And all that would happen if the x and negative x switch would be that the slope of our graph would then also switch of our data. However, the magnitude would stay the same, as the signs only implicate what direction it is going in. The second one was a what does it mean? Your observations can be predicted well by your computational model when you set the net force equal to 0 in your model. Is it possible for you to say how many pushes and pulls, or how many forces, are added together to give a 0 net force in the case that you observed? And then in this experiment, it is hard to know all the forces that could have been acting on it. However, there are a few that we definitely could identify. We know about the gravitational force of the Earth pulling down on the ball and the normal force of the floor pushing up on the ball, which would then cancel out and give 0. And then there may have been a slight frictional force that we must account for, as we saw a difference in the predicted position and the observed position data. Thank you for listening to my lab report.